half of the section. This is the portion that I delayed a day because yesterday was kind of better spent working on the first style problems. This section wasn't really intended to take 4 days, but it may take us 4 days. And that's okay. Well, like I tried saying yesterday, I'm not going to rush it just to finish it at a certain time, because that doesn't really help you or benefit you. So. This is the exact opposite of what we were doing the last 2 days. So the last 2 days, you had a logarithm equation that you were trying to solve, and the way that we solved it was to take it out of logarithm and into exponential form. Basically, you can convert back and forth between the forms to use whichever one would find you the answer. That's kind of what we're doing. So on this one, we're trying to solve for an exponent, right? Oh, that's a very fat marker. We're trying to solve for that exponent, and so exponential form isn't really beneficial for us. So if we want to solve this one, we're going to change forms. So we're going to change this to logarithmic form, and then this would say log base 5 of 30 equals x. I'm kind of under the assumption that you guys are getting much better at converting back and forth between them, because we've been doing it like a week and a half now. If you need help with that, though, that's definitely something you'd want to get help with. And at this stage, this is when you would just basically type it in the calculator or kind of figure out what two numbers is between. Hi. A lot of slips. Is any for me? Because I want to leave. JP. Evan. They're not for me. What happened? I want my parents to call and give me a pass. My dad's subbing here today. He should call me out.
Is he the one who won?
Usually.
Oh my god, it is him.
Well, you didn't believe me when I said it? Or?
No, you never told me. Ava told me. I told her. And she
Oh.
What?
Yeah.
Oh.
He. Yeah, a long time ago.
Yeah, because he knows, like, he helps us.
Yeah. He subs at my school and my brother's school.
Your brother's a teacher too?
Yeah, he teaches at St. Anthony.
Is he a math teacher?
No, he is terrible at math.
What kind of teacher?
He's a social studies teacher.
Why is it
It's like Miley's favorite subject. It's kind of weird.
teaching runs in the family, I guess.
I was just gonna
Well, we're the only 2 out of 5 that teach. So it's not like it's like a family thing, but it's, yeah, kind of.
Your dad teach, you teach.
Taught, yep. Let's not use the word teached.
Your dad teaches.
Okay, so this answer, if we used a calculator, would be a decimal. If we had to estimate the answer, it would be between 2 and 3. Well, I was just going to call on somebody to answer that, yeah. Evan, do you remember how I would figure out the answer is between 2 and 3? Like, how did I know that? If you don't know, that's fine. I just call on you, kind of at random. How did I know the answer is between 2 and 3?
Oh, that's actually good.
Hi, you made it.
I did.
Thanks. If the answer was exactly 2, what number would be there instead of 30? Yes, but you're whispering to the wrong person. I knew the answer. 25. If this was 25, then in your head you could think 5 to what power is 25? and that would be 2. And so I know the answer is a little bit bigger than 2. 5 cubed is 125. That was one of your homework questions yesterday. So I would just know that 30 was in between 25 and 125. And I don't know if you guys are allowed a calculator or not yet on this test. I believe you are. So you might not even need to worry about this. You could just type it in. Flashback. Yeah, okay, Charlie, question.
Can you remind me how to type that in my calculator?
That was exactly what I was going to ask somebody. Good thinking. Anna? Do you remember how we would type this in a calculator, since your calculator doesn't usually let you type it straight in there? No. Oh. I was calling on you to be a hero, a savior. Nothing? Nucci? Very close, but very backwards. Yes. So in your calculator,
Yeah, I'm gonna eat decimals.
you would do log 30 divided by log 5.
Oh, what's that way? Or thinking of the other one?
That would be like 2.2 or something like that, 2.1. Did anybody type it in yet?
No. I mean, wait.
Say what? I heard somebody say something. What'd you get? 2.11. Go ahead, Maddie.
Why would you do like why would you type in the calculator?
It's called change of base formula. I mean, I know you're looking for a reason for division, but the answer is a lot worse than anything, so I'm just going to leave it as go with it. This was basically what you got tested on your last test that I have to finish correcting and hand back to you. Okay, so this is the basics. Most of the questions you're going to get are more difficult than this. This is kind of like the basics. Are we ready to step it up a notch? Okay, even if you're not, we kind of have to, so. Ooh, worse. Oh, that's not good. 9 to the x equals 3 to the x minus 2. Oh, that's not good. Ooh.
Oh, that's not good.
Let's see. Henry, why is this kind of an issue?
Because you can't really have exponents on both sides.
Yeah, so changing to log form works best if it's just one side, correct? We could theoretically use change to log form, and it actually does work, but it's just a lot of steps. The part that makes this most difficult is that they have a different base. So if they both have the same base, well, then we could just figure out the powers because they would be equal. It's kind of like yesterday. Remember how when we had questions that said log of something equals log of something, and we kind of just like canceled out the logs? If we have the same base to the powers, we can kind of just cancel out the bases. And we don't actually cancel out the bases, but that's what it looks like, and it's easier to explain. So how would we change these both to the same base? Would we be able to write them both as the same base to a power? It's hard to talk today, okay? 9. How could I write 9 if I wanted to? 9 is a version of 3. Kind of. So 9 could be written as 3 squared. What you're saying was correct if you did the square root of 9 as 3. But I could write 9 as 3 squared. So if I write this like that, This is gonna kind of rely on a little while ago. Remember when we did all the exponent power rules? A power to a power, you can multiply them. So this could be written as 3 to the 2 times x.
What if it's added?
If they are multiplied, then you add them. Now that I have them both written as 3 to a power, I can sort of do it like this. Like, this isn't really what happens, but if they both have the same base, then I can kind of ignore that and look at just the tops. Because everything else in the problem was equal or the same, I just focus on the parts that are different. And then I can solve this like a regular question where I subtract x.
That's it?
Yep. How is
Oh, that's it.
how is this feeling so far? Does this feel easier than the log ones from the other day or not?
Up to one example.
Unsure yet?
So, you said when there's an adding and multiply?
If you have a power to a power, like the one that I had written there, so I had 3 to the power of 2 to the power of x, then you can multiply the powers together. If you had 3 to the 2 times 3 to the x, then you add the powers. That was the property from a while ago. And it definitely can get confusing switching between them. Okay, let's go to a little bit harder.
Yeah, it's cold in here.
So 1/4 and 1/2. Obviously, they're different numbers. My goal is to figure out if I can write them as the same number to different powers. There's actually 2 totally different correct answers to this one. Can anybody think of either one? Which one could I change so that it... Are you trying to answer?
Yeah, you can square 1/2.
Okay, good. That's one way that would work. 1/2 squared is 1/4. I don't know which one's going to be easier for you guys to picture or visualize. The other correct answer is that these are both powers of 2. So the one on the right is 2 to the negative 1 power. The one on the left is 2 to the negative 2 power. Now, I have a feeling that it's easier for you to picture 1/2 squared as 1/4. Maybe not. Some of you hate fractions, like with a passion. Okay? If you hate fractions with a passion, then this is going to be the easier route for you, probably.
We're doing -2, -1.
A negative power means it moves to the bottom of a fraction. So 2 to the negative 1 power would mean it moves to the bottom of a fraction to the first power.
And where'd you get 2 from?
Say it again.
Where'd you get the base 2?
How did I even figure out it was a 2 to begin with? Because 2 and 4 are both powers of 2. So just
You're only
being
looking
on the
at bottom.
being on the bottom of a fraction actually doesn't change that. It just means it would be negative powers instead of positive.
I'm just confused on like the 2 to the negative 2.
Like what that means.
Yeah, like how you got that.
I just knew it. So 2 to the negative 2 means 1 over 2 to the positive 2. A negative power means bottom of a fraction. The number doesn't represent anything. The negative symbol means bottom of a fraction. So when I see a 4 on the bottom of a fraction, I know that that's 2 squared. But being on the bottom means it's a negative.
Oh. Oh, okay.
And then to finish this one, we will, oh shoot, what did I do? To finish this one, I would do the power to a power thing like on the last problem. So this would become negative 4x. This would become negative x. And then this problem is actually becoming kind of a dumb answer. But we're going to get an answer, so that's always good. Is anybody picturing what the answer is going to be? 0. It's kind of dumb, but... Okay, well, I'll finish the problem. So now that we have the same base, we kind of ignore the bottom parts because they're already equal. And we focus just on the top. So this would say negative 4x equals negative x. And I get the x's on one side. And I get the regular numbers on the other. I've got no regular numbers. So I get 0. Zero is an answer, it's just a bad answer.
Is that supposed to be a 1 or an arrow? It says plus arrow x. Oh, you're bringing down.
Plus 4x.
You're bringing down.
Is that what you're talking about right there?
Yeah.
That says plus
I thought it
4x.
was. It looked like an arrow.
Really?
Yeah.
Oh, that does look like an arrow
Wait,
down.
how is that a 4? Oh. You just crossed it really low at the
It's
top.
really hard to write on this thing.
It's kind of fun. I've always wanted to.
You're welcome to.
Okay. Yay. Thanks.
You have to have a lot of coordination to be able to write while looking at something else.
That's pretty.
How are we feeling about this?
Another example. I think.
I don't think I have any more examples in my notes.
It's fine.
Oh,
This
eh,
one's
okay.
interesting.
So,
Nice.
what time we get done? It's shortened. What does it get done?
15.
15.
Another two.
I don't have any more, but I mean we can make some up, I guess.
Thing that we have to do?
Yes. So why don't I just give you your homework? I can put the homework up, and we can kind of do the first problem together.
Yes.
That sounds like a plan.
So it's the same worksheet from the other day. We'll do worksheet B, but 1 through 9 because that's. I'll post it in today's folder again. I just haven't had a chance. We had a meeting this morning.
Oh god.
I don't know if anybody has worksheet B open already. Wait, I got it down here. I downloaded it. Worksheet B, number 1 is 5 to the 2x equals 20. We should do question 2. 1 and 2. Wow, you guys are kind of needy.
Well, we only did 3. Yeah.
1, 2, and 3 are all similar. I think I should do 4 with you though. That'd be all right.
Is it the 20? Oh.
26.
Ooh, I forgot to turn my homework again. Wait,
Okay, so question number 1. When I'm looking at this one and I'm trying to solve for an exponent, that's specifically what logarithms are for. So if I'm trying to solve for an exponent, I'm going to change this to log form. Okay, so log form would be log. These are the same numbers we just had. Oh, no, they're not. Log base 5 of 20. I was thinking 30. Equals 2x. So this is definitely going to be a calculator answer section, I'm guessing. So log base 5 of 20 is going to be some sort of decimal like 1.7 or 1.8 or something. And then at the end, you divide by 2. because it said 2x. So x is going to end up being like 0.9, 0.8.
Wait, you do log 20 over log 5? Or no?
On the calculator, log 20 divided by log 5. Hit enter. And then hit divided by 2, enter.
Log 20.
0.89?
You just write log numbers.
0.93.
Are you running with the temp?
Doesn't matter. Doesn't matter.
0.93?
Sure.
Okay.
Okay, question 4, the other style. What base should I change those both to? So we've got a 16 and a 64. 16 should immediately kind of raise some, you know, spidey sense for you. What is 16 from? What do you usually see 16 from? 4 squared. You have to think in terms of powers. I mean, saying 8 times 2 is definitely right. I was thinking in terms of powers. So 16 is 4 squared. So that means, can I write 64 as 4 to some power? And that might be harder for you to know off the top of your head, but 64 is 4 cubed. You can use your calculator to figure that out if you need to. So I can change these both to 4s. So I've got 4 squared to the 5x. And the only reason I'm thinking of trying this is because I've got 2 different powers that I'm trying to solve for. That's 4 cubed. Okay. So now I'm going to multiply the powers. So 3x plus 21. And then now that I have the same base but different power stuff, I'm going to focus on just the power parts. And then 10x equals 3x plus 21. Subtract 3x.
Dividing 7, 3.
Correct. I ran out of space, but
You get the point. What was I doing for that?
there you go. I did 2 of the 10 of them, 2 of the 9 of them for you.
Thanks.
You got 15 minutes. I would think that's probably just about perfect timing to be able to get the rest of it done. But that's this other